Alright, in this lesson we're still looking at factoring completely, but we're looking at moving into this third level here of using trinomials. So we still have to look for GCF, but then we're going to see problems that instead of having binomials, in other words two terms, we're looking at things that have three terms. So that looks like these problems. So these are trinomials, and we have to think through how far we can continue to factor. Now a lot of these are going to look like ones we've already done, because we have. And we have to look for two types. There's our first type, which was just factoring using the magic x, and then our second type that we learned, which was the perfect square trinomials. Okay, so we always want to be looking for those because it makes our factoring a lot nicer. 25 has a square root of 5, so the question is can you take this number out in front, the 1p, and multiply it times 2, so 2 times 1p times 5 to get 10. And since we can, we want to use the perfect square trinomial factoring, which means that this just turns into the first number, p, plus the second number, because there's a plus sign, and then parentheses squared, because that makes my life a lot quicker and faster. If you don't have perfect square trinomials, then you would have to do the magic x, for example, in the second problem. This one, 6 doesn't square root, so I can't, neither does the 2, so I can't do perfect square trinomial factoring on that one. So I start off looking for a GCF. There isn't one, so I have to do magic x. I look for 6 times 2, or negative 6 times 2, which is negative 12, and then I put negative 1 on the bottom. So I have to think through my factors of 12 that add to be negative 1, and if I get negative 4 and positive 3, I do multiply to be negative 12 and it adds to be negative 1. So then again with my magic x, I'm supposed to divide it by 2k without the exponent. And that gives me, I can reduce this to be negative 2 and this to be 1. So that gives me k minus 2 times 2k plus 3. And then I have to look at my answers because it's factoring completely, and because there is no common factors or anything like that, this is my final answer. So it's just like we were factoring before, but I just have to make sure at the last step, is there any more factoring I can do? Okay, now we've got two more problems here. This first one, again, I'm going to look for, is this a perfect square trinomial? Because I'm looking at 16 thinking, alright, that square root is to be 4. Now I think about the number in front, that's a 1, so the question is this number in the middle 2 times 1 times 4? And the answer is no, because this would have needed to have been an 8. Okay, so I go backwards and think through factoring using magic x. To put a 16 on top, negative 6 on bottom, and then I look at what multiplies to be 16 that adds to be negative 6. And most of our minds go to negative 8 and 2. And we think that that will work. And usually you'll jump ahead and actually write that down as your answer. But you got to be really careful because that actually does not factor. The reason why is because negative 8 times 2 would have given you negative 16. And that does not give us our positive 16 that we're looking for. So this problem doesn't factor. Next problem, it's kind of out of order, first of all, but you can see that the y squared is in the middle. Usually it would be x squared minus 4 minus y squared, and that looks like how we're used to seeing these problems. But regardless of either way that it's written, because of the fact that there's no xy in the middle, this isn't a regular trinomial that we're used to. It would have to be something like x squared minus 4xy minus y squared for me to even try to factor it, but either way it doesn't factor. So backing up here, because there's no GCF, there is nothing we can factor. And because there's not the usual pattern, like I said, x squared and then xy in the middle, and then the y squared. Because it's not written like that, there's no factoring I can do with this particular problem. So we say again, it does not factor also. Okay? Alright, I'm going to finish this lesson off with a grouping problem. Now, what you're looking at here is the fact that there's 4 terms. And so on that list I gave you at the beginning of this lesson, you can see that number 4 was grouping. And so what that means is we factor by grouping before. I draw a line down the middle, and I look at the first two and say, what do they have in common? And they have an x squared in common. You write your leftover, which would be x plus 2. And you need your second term to have the same binomial factor. They both have a negative 1 in common, so I factor out a negative 1. Leftover would be an x plus 2. And you can see they both have x plus 2, so you factor out an x plus 2. And if you factor an x plus 2, you're left over with x squared minus 1. And the reason I show this problem is because it's part of the factoring completely series we're doing here, which is that this is not factored completely because there's a difference of squares right here as part of your answer. So you have to rewrite this now to be x plus 1 times x minus 1. And then you still bring down your x plus 2 that was in front. And once you've gotten to that step, you can say you factored it completely. Okay, so that's an example of grouping where you have a little bit of factoring completely at the end. Usually it's just the last little bit of difference of squares that you're looking at. And again, remember, don't let the 1 confuse you. The square root of 1 is 1, so it does actually do difference of squares.